We're live. How Milo? Huh? What are you doing? Huh? What are you doing? Milo's up here with me every morning. He wants to be part of it all. He wants to be famous, he said. He wants to be an influencer of other golden retrievers. Tell them to do the right things. Milo. To be good doggies, huh? Yeah. So how's everybody doing? Today we are going to talk about intake manifolds, more specifically 4.6 liter 2-valve intake manifolds. That's right, we're getting specific, although the things that we learn on this you can apply to every other intake manifold too. In some cases, there's lots and lots of stuff to choose from. If we take a look at a small block Chevy, lots of intake manifolds. Small block Fords, lots of intake manifolds. LS, lots of intake manifolds. Even the LS3. The LS7, there's not a ton for, I don't think, although I think that that's a fairly small market. But that becomes the problem, is how big is the market for people that want to jump in and go to the expense of making a casting or a composite intake manifold? Do they want to go to that expense? Think about when Comp and when they were doing the thing with Wilson, who designed the original fast intake manifold. They had to go through not just the design phase and testing phase, but it was a very, very expensive procedure to build all of these intake, to build the machines and stuff that put together these intake manifolds. And so it was a very expensive proposition. But I think that they had a big list of people waiting for that intake when it came out. And look at the LS market. It was a huge market. So it was less of a gamble, I think, than, but early on, it still was, because you don't know, I don't think anybody could have known that the LS would supplant the small block Chevy, or at the time, really, because the big thing going at the time was more the small block Ford, that it would supplant that as kind of the go-to thing and have it blow up the way that it did. But as nice as it is to have all of these intake manifolds available for you, there are a lot of applications where you don't have that. You just don't have 15 or 20 intake manifolds to choose from, or to confuse you, because sometimes that happens too. Well, what about this one and this one? Well, you're kind of nitpicking. A good example is, how is the high ram better than the ProFlow intake manifold? Even though they look different and design wise they are different, when you run them, they're very, very comparable in power. And when, for most applications, you're nitpicking what they do that's different. There's a lot of other choices that are like that, where you end up getting the same thing. And so that's one thing that having lots and lots of choices does. People get confused, which is why I do so much testing, to tell them, hey, look, this one's 4 horsepower more than this one. You know, maybe that does or doesn't make a difference for people. But in instances, and then I find this weird too, that and that some of that has changed a little bit on the 4.62 valve. Obviously, Ford all but replaced the Windsor motor. They were still doing it in the trucks for a little bit, but they replaced the very successful and long run Windsor combination, and having been the darling of the aftermarket industry for a long, long time, the 5-liter Ford, they replaced it with the modular Ford, and they used it in all the Mustangs and had been using it previously in other applications, full-size cars and stuff. And so they made a ton of them. That's what I'm saying, is they made part of the problem with the 4.62 valve is that they made 2 different versions that had different heads and different intake manifolds on them. They also made 5.4 versions, which don't share the same intake manifold. They do share the same head and camshaft, but they don't share the same intake manifold because of the deck height of the block. So that's different. So you can't run intake manifolds, the same intake manifolds on both of them, unless they're like the intake manifold that I have in the thumbnail. Then you can, because it's independent and doesn't really care because there's 2 sides to it. It doesn't really care what the deck height is. So it'll fit both of those. In fact, the intake manifold that I started with was from a 5.4, and we'll get to that in a minute. I think it was, if I remember right. It's been a long time. But when I did this, there weren't a lot of available options. I thought that people would be just throwing intake manifolds at these things, and because they made so many of them. I told people for years and years and years before TrickFlow finally, Brian Truly, I actually designed the 4.62 valve cylinder head, and I had been screaming at people for years and years and years, look, somebody needs to build a head for this. Because if you do, you're going to sell a bajillion of them. I was thinking like you guys did for the 5-liter Ford, especially if you were the only one in the market. I thought, hey, you're going to sell a bajillion of these. And you also need to, obviously have a corresponding intake manifold. And so eventually the 4.6 2-valve market kind of developed. We had a number of intake manifolds. TrickFlow has them, and we had the P51 and the Reichert Racing fabricated kind of deal. I think Edelbrock now has done some carbureted style intake manifolds for them. What else am I missing? Obviously the factory PI intake, and what they did was sell a lot of elbows, throttle bodies for the factory intake manifolds. But what I did way back then is because there wasn't a lot of them, and the ones that I had seen didn't really perform the way that I hoped. They didn't gain a lot over the factory PI intake manifold. It actually turned out to be a pretty good intake manifold, especially in the RPM range that it was designed for. So up to 6,000 RPM or so, it was actually pretty good. It was what we saw more often than not. Was kind of like with the LS3 intake manifold, is that you could make more power. The Reichert Racing one, the short runner deal, is a good example. You can make more power, but you make a lot less for most of the curve. Maybe you could pick up power at the top, but it's going to lose a whole bunch. And that's not typical of, it's typical of all manifolds, of all short runner manifolds, not just that particular one. They all do that. If you put together something that has short runners, and in this case, I think it was done for, ease of fabrication. When you do that, it just makes less power through most of the curve. We saw that on the previous 5-liter Ford with the box that you replaced the upper intake manifold for, which everyone thought was restrictive, but they didn't really understand how runners or how runner length affects things. But it was restrictive. It didn't flow as much as it needed to. A GT40 flowed more, had similar runner lengths, and so you could make more power with it, because in addition to making power in a given RPM range, which in the 5-liter Mustang was, very, very, very low RPM, and in the 4.6 2-valve stuff was like that as well. But the 4.6 2-valve also had the non-PI stuff, and then the PI stuff, which you didn't interchange those two things. You could swap the heads and intake manifold because they went together because of the port size, and also because of I think that the water jackets were different also. And I remember guys welding those up and making it so that you could interchange the intake manifolds on them, or run the PI on the non-PI head stuff. But the non-PI head was actually never very good. I remember doing ported versions of those, and they just didn't turn out nearly as good as the ported PI versions. But in making an intake manifold, so what I did, all of this goes to me just talking about the fact that there weren't very many intakes. There was nothing making the power gains that I thought that they should or could have. So I just decided to make my own. And when you decide that, and you have an application where, hey, there's not a lot to choose from, or I want to make something cool and custom and super richy, then you do it. And the easy way to do that is to not, the way that I did it is to not make everything yourself. So now guys can rapid prototype or 3D print stuff. If you can draw it up on if you have that kind of talent, you can draw it up on a program and then have it just print out. That's really cool. That's like science fiction for a lot of people. But what I did instead is I used something that was already existing. In this case, I think it was I can't remember if it was a 4.6 or a 5.4, but it already had an aluminum base structure. And what I did was we just got rid of most of the manifold, and then just used the flange that basically bolts to the head. And I think also the crossover, I'll take a look at that. I think also the crossover for the water passage. Take a look at that and see. Yeah, so this must have come from a 4.6 2-valve, like a truck manifold, if I remember it. So what I did was we took that manifold, we cut off, just use a Sawzall or whatever, and just cut off the rest of the manifold, all the long runner stuff, and just threw that away. And then what I did was I made pieces of just simple tubing. I think I used 2-inch, and then I swedged the end of it. And these were bends just so that we could get the thing to come up and go straight. Because what I wanted to do was I wanted to be able to add rudder length and test whatever I wanted. And you can see the way that the plenum is designed. It has standoffs on it too. It has radius entries inside the plenum. You know, it has a big mailbox shaped common plenum that we just use. We just use a piece of tubing, a bigger piece of tubing. You can use a 4-inch or 5-inch. And we start with that and then cut part of it, put a plate on it, put holes in the plate with a hole saw. You know, none of this is terribly difficult because I can do it. The only part I didn't do was the actual aluminum welding because I don't know how to TIG weld yet. So you just draw it out on paper, or in my case, make it out of cardboard and go, yeah, it needs to look like this. And we use that as the template for the other pieces. But on the base, so we cut that stuff off. And the reason that I did that is because it already has a lot of the stuff that you need and the stuff that can be fairly time consuming to make. So it already has, you know, it has the bolt holes to bolt the thing down. It has the opening for the port. You can open those up, especially if you cut most of the intake manifold off, then port matching it doesn't take very much because you don't have to remove too much material. It already has the provisions for the injectors, so you don't have to drill and ream that and get those positioned properly. It also has the mounts for the rail and injector, and all that stuff can go there. It just makes it, if you're doing it yourself and want to do it as quickly and as inexpensively as possible, because you can go get one of these intakes to start off with from the wrecking yard. It's cheap. Aluminum tubing is not terribly expensive, although now it's probably quite a bit more than it was. But I just made the bends thinking ahead of time that I want to be able to stack this up and raise this thing. And it's easier to go straight up than it is to go at some weird angle or to cross or something. It's more involved that way. This just made things easier for testing. So I flared the ends, had the elbows welded on so that they all were, you know, they don't even need to be perfectly even. They just need to be fairly even, just so that the plenum that we made that has the standoffs on it will all go down into that. And then so each section of tubing that I made was I just cut lengths of aluminum tubing. I cut some 2-inch, 8 2 inches, 8 4 inches, 8 6 inches, 8 10 inches, whatever, and then took them over. And the muffler shop guy, a local muffler shop guy, before they become big in Hollywood, used to just let me use the flaring machine. I would just flare the ends, and then that way that they would all just slide into each other. They would just, you know, and that way we could push them all together. And for testing, all we had to do, originally I was doing, like, I would go to Home Depot, but this was kind of expensive. I'd go to Home Depot and get the rubber connectors for tubing, and then you'd use 2 clamps, and then that would seal the area. Now I just use Gorilla Tape because it's really good, and for testing it works out very well. Obviously, and we could run boost on it too, because actually the boost it would hold quite a bit of boost if we use Gorilla Tape. And I think I may be doing a test on that later on, to just use tape on the discharge side of the turbo application and see how much power it will take. Because I think honestly, if depending on how the tubes are lined up, it would take a lot. And because these tubes are slip fit one into another, they're not taking a shearing force on the tape. So I think it actually worked fairly well. So I just made all these slip fits, and then I could slide the plenums into all these slip fits. And you can see that's one runner length that we ran there. And we made the flanges on the front of the plenums. We angled those so that you can see we can run the throttle bodies with the openings with the throttle linkage in the same position. Just run a wire from one to the other, and then that way all I have to do is run one throttle wire over, and we're pulling both of those open. Because on the dyno, we're not worried about drivability with syncing the throttle bodies. All that has to happen is they both have to pull all the way open. And after tightening the wire a little bit here and there, that's actually fairly easy to get. So we can do that very simply. Anymore, what I do is I make the flange that holds the throttle body. I just do a standoff and then another standoff on the plenum so that I can orient the throttle body however I want. And then that piece I'll use a silicone coupler on with hose clamps, just so it has some strength and so that it's not really long either. So once we clamp it in place, it's not going to go anywhere. And that allows me to orient the throttle body if we have to adjust it. And sometimes we do cross ramp stuff and weird stuff, and it makes it a lot easier. It also sometimes makes it easier to route sometimes we have to do dual cables and run them through a pulley system and stuff. You just got to make it do whatever you need to do for the dyno, and it works out pretty well. But doing this system this way was the least expensive way, other than buying the rubber couplers for me. And like I said, ended up using tape after that. But it allowed me to not only make a manifold, and I wasn't going to make one manifold that I thought was going to be the ideal combination, because you don't know what that is. and I say you don't know what that is, not because you can't do the calculations. I can't do the calculations. Even with the book that I have, the calculation for this is not only is it very complicated, but it's also, even if you were able to do it, if you knew all the variables, you could plug them into the formula, it's going to tell you a single cylinder thing. So it's not going to actually tell you what the power curve is. It's going to tell you 1 point. But I like to see what happens to the whole curve, because what does happen, and why it's hard to pick the ideal combination, is because you're going to have to make a choice, not in how much power you want, but how do you want this affecting the rest of the curve. So we could run the short version that you see there in the thumbnail, or we could run really, really long ones, because I just stacked tubing up and we made runners that were, I don't know, 12, 13, 14 inches or whatever. I can't remember how high we went on that, on the two valve stuff. On this particular two valve that we ran it on, that made 490 horsepower, I think, with the best combination with a short runner deal. It had good cams in it. It had compression in it. It had ported heads. It had, I think it was also not a 4.6. I think it was a 5-liter stroker, I think, if I remember right. So, but you're going to tune the intake to make the power where you want it to make. Because remember, that's what intakes do. Intakes help decide what RPM range the motor is going to be effective in. So shorter runners, you're going to make power higher if you have the other things to go with that. You're still going to shift it a little bit, even if you have a mild cam and stock heads. A shorter runner is still going to make power higher in the rev range. It's just not going to make as much as if you have a bigger cam and ported heads to also support making power up there. So it makes more power, and then the RPM range that you're running at, the intake manifold, is going to help kind of dictate that. The cool thing is being able to adjust it and see, and also the terrible thing is being able to adjust it, because when you adjust it and you add runner length, you roll into the throttle at 3,000 RPM. You're like, oh yeah, good things are happening now. And then you let it go through and do its thing. You're like, it's falling off now at the top. And then you shorten the runner length and you roll into it. And you're like, it's not nearly as good. Oh, but it's getting with the program now. And then you do the short one. You're like, oh, that's terrible. That's really, really soft. And you're like, oh, it wants to party now at the top end. And so you get to now decide, okay, which one of these trade-offs do I want? And obviously the ideal thing would be to have a dual runner thing that switches over, or one that intermittently adjusts itself, like we've always talked about. But it's kind of cool. I love doing these adjustable things, because you can also see that in addition to adjusting the length, we also can adjust whether or not we join the two plenums. You can see the big connection on the back. I put standoffs on the back side of the plenum so that we could join them together or not. And also, when we're joining them together, if they go out at an angle, which this one did, and not go, I think this one did not go straight up and down. Most of them that I did went straight up and down, so that I didn't have to change the length of the connector. That's what it was. But if we change the length of the connector, that adds plenum volume, so that changes something, having it connected or not connected. Originally, I just wanted to put a throttle body in between there, so all I had to do was open and close it, thinking that, like the original 4.62 valve truck manifold, that we could open and close it at some RPM where it would be beneficial, and then we could have the best of both worlds. I actually never did that. The connection between the two, having it or not having it, definitely changed the power. So it could have, it could have done something. Also, not shown in here were 3-inch extensions that I ran off of the throttle body with radius air horns. And then the length of those stacks made a difference also in the power curve, in addition to improving the flow rate. Although, because we had two 75mm throttle bodies on this motor, we had more than enough throttle, and we had very little vacuum present in the intake manifold when we did it. So if you're going to make something, the thing to do is to start with something that already has lots of what you need there. And then, like I did here, you could make it adjustable if you want it to be adjustable. If you wanted to take an LT1 second gen and put lots more plenum volume in it, you just cut the top and put a big mailbox thing on top of it. If you want to add runner length to one of the things I was going to do when they first came out was the Holley high ram. I had drawn up an adapter plate that went between the lid and the bottom section that basically slid in, and then added runner length with bell mouse on it, so that it would be inside the plenum, and it would also have an extension. And I just did the extension not because I cared about increasing plenum volume, but more because I cared about increasing the runner length, which I knew would change the power, because a Holley high ram compared to a fast manifold loses power through most of the curve. So we wanted to see if I could then improve the high ram and give it more effective RPM range. Like, instead of being it makes more power past 6,500, could I get it to draw that back? So from 55 to 75, it was better, kind of thing. So that was the idea behind that, but I just never ended up even testing it. So, but that was one of the ideas. So if you want to do stuff like that, start with something that you know is going to work, like the tune port deal. A tune port, obviously, a lot of guys had tried different things, bigger base manifolds that flow more, different runner lengths, Siamesing them, the short runner lengths used on the Excel Super Ram. So you can do any number of different combinations. One of the things I wanted to do was make the runner length a lot longer. and then I also had, when I originally started doing this with the L99, one of the things I wanted to do is we wanted to make it longer, but I also wanted to do a dual plenum version of that. We have two of the factory plenums joined together by standoff tubes, and then have, I already had drawn out a way to cut and extend the factory turns on the tubes and make those join way out, so that it's just a spaceship looking thing, because we're all kids. That's why I wanted to do that. So those kinds of things are really cool. So I recommend trying that with different things, like putting the carburetor on top of the plenum on the tune port thing. Didn't work out very well, but it's a cool idea, and it's definitely an idea worth testing. And obviously YouTube will love you for it if you do weird stuff like that. So let's see what you guys got going on. And here, this is the morning inspiration speech. Go get your projects done, because you should. That's why we're here. So let's see what you guys got. Let's see. So when we start talking about runner length, someone always brings up the 787 Mazda. BMW did a trick continuously variable intake manifold. That was really cool. Kind of like a scroll. It was pretty awesome. We ever do Ford 2.3 liters? I don't have one of those. Mark Sanchez actually has one. It's not a turbo version. It's a later NA version. In fact, it might even be a 2.5, but I think it's damaged. What is the best turbo? 1,000 horsepower 5.3 for BTR cam, stage 2, 706 heads, Trailblazer, forged internals. A single turbo is easier to do, and that's an S475 or 7875 Gen 2 from VS Racing, or an S480. All of those turbos will do 1,000 horsepower stuff. So Zach, you got electrical tape. You must have used a lot of electrical tape to go 32 psi. You move the injectors away from the intake valves, you get more power from charge cooling. Does it change or delay throttle response? I don't think so. Twin M90s, that's good. That's good as a G-Wiz thing. So Michael, you're happy to give up 30 foot-pounds for 15 horsepower at the top, and then you fix it with gearing. If drag racing and ET or whatever is your thing, then that can work. Java, you made it. Yesterday I got to work. Michael, I'm glad, man. Yesterday I got to work on the project car for the first time since the hurricane. So did you get your stuff all cleaned up, or as cleaned up as you could? Well, I want to ask a few questions. You don't have to ask a question to see if you can ask questions. Just ask them, man. And welcome. Saudi Arabia is in the house. Norton's Engineering got them kicked out of racing. At one time, you could get a turbo for $160 to $2. Mark deals with 2.3 stuff. Last time I talked to him, he only mentioned the modular 2-valve. No, Mark Chenchez has been doing this since way before 2-valve stuff. He does like modular stuff, but he's done, when he was back doing stuff with, when Advanced Engineering West first started, and when he was doing stuff with Kaufman, that was all the 5-liter days. Oh, I didn't, dang it, I didn't do my fault. So if we're having noise, it's my fault. I didn't choose the mic again. I'm going to have to put up a 462 valve and adapting intercooled Terminator M112 or GT500. First time planning to get the engine running on Megasquirt. No, the Megasquirt stuff works. Michael, I'm glad you got that stuff replaced. Yeah, the sound is probably back because it's silly thing. I don't think I can go back and. What happens if I click this? No, let's see. Is it letting me do any of this? Let's see. Nah, I can't go and select it anymore. That's on me. That's not bad. Do you still have the intake? I think I do. Can't stand the look of all the small look Ford and modular Ford intakes. They all look terrible compared to TunePort. I know I do need to put a post-it note on there. Don't make noise. Would I sell the modular Ford intake? Yeah, it's been sitting around for a long time, so I think I would. It is the rattlesnake. It might be Milo making noise. No, if he's making noise, he'd be snoring. I'll be heading down to West Tech pretty soon, so I'll take a look and see, make sure that I have all the pieces for it. Yeah, Milo's on guard duty right now. Although they would have to come in and trip on him and wake him up and then just pet him. Richard, do you still have any road course? Do you have your coupe? Yeah, I still have. It's an original owner Mustang, so I'm going to keep it. I don't know if I have any videos of it. GM had a bad batch of shocks. It went on Trailblazers. If you worked the throttle just right, you could get the front. So what did you have to do? Bounce it maybe or something? I use the photo in the thumbnail. I use those plenums and attachments and throttle bodies also on the 4-valve stuff, because I made a 4-valve version of that too, and those went right on that too, because I made it the same. Excuse me, I made it the same way. I made the a 4-valve base flange basically with standoffs on it, and then I could stack tubes on it. And I did the same thing for the for the B-headed version as well. Yeah, Dan, I've seen guys do that. We had a guy that I went to school with that used to buck his Bronco like that. He had the early small Broncos, and he used to bounce it up and get the wheels off the ground. Oh, Dean, that's right. There are videos up of that car at speed on the Silver State, because they were filmed in VHS way back then, and I think that there's still stuff up there. If you do Silver State Mustang or Richard Holder, do a search for that's probably up there. I might have one or two of those old tapes. VHS is back at high school. Richard, I just sent you a photo of the intake. The question is, have you ever tested the FR500C? I think I have seen those. They use those on the Daytona prototypes that they ran with modular Fords, but I don't think I ever ran one. All things being equal, what does a change in plenum volume do to the shape of the curve? I haven't seen it do anything. The only time I've seen plenum volume make a change was at very, very low RPM on the 462 valve truck intake manifold, where they have a divider that changes the plenum volume, that connects it and unconnects it, basically, that joins the two sides. And that's the only one I've ever seen do anything. I've made fairly big changes and not seen what I want to see on my motor. Got to throw that in there every once in a while. Got some top secret stuff over here. So I can look that up. Let's see. Trying to locate a photo of that. And actually, the one that I click on is taking forever to load. Okay, I don't have time for your nonsense. So that's okay. There we go. Yeah, that is kind of cool. Very, very cross rammy. So let's see here. Oh yeah, that is pretty fancy. And notice the injector placement on those. And the staggered trumpet. Interesting exhaust. Yeah, that's kind of cool. I don't remember seeing one of those in person, though. Howland, you got a 671 BDS with twin Hollies on it. It hunts at idle. A lot of blower guys, like especially in boats, they kind of like that. I myself don't, especially in a jet boat, or even in a prop boat where the thing is surging. I would rather have it be stable. Any interest in the Mazda engines Ford used, the 1.8 liter four banger and the Escort G? I do like Escort GTs for the 2.5. I have interest in every motor. Richard, which 5-speed transmission would you recommend for a street car with 500 horsepower Ford? I don't know, a TKO or something maybe. You plan on testing a 1UZ? I don't have one of those, but they are available in the wrecking yards. So you guys are comparing your computers to your cell phones? They have a lot. They do a lot of stuff now. The Tremec TKX is the newest TKO replacement, overdrive fifth with a strong torque rating. See, something like that would probably be okay. Yeah, Dan, that's why I don't like the surging for low speed stuff. And obviously with the blower motor, you don't have to worry too much about the thing getting up on plane. I like that FR500C intake manifold. I like the cross ramming thing. I'm surprised somebody hasn't duplicated that. I would think that that would be the go-to thing. That reminds me a lot more of the Coyote intake manifolds. And I like their injector placement too. That's kind of cool. You know that helps with power. Can you guys hear that? Milo's growling in his sleep. He's having dreams. He had to chase turkeys yesterday. I think he's remembered. Oh, I think he caught him. So you want to make a sheet metal 2V intake? Yeah, the Reichart Racing piece from back in the day. I don't know if they still offer that or not, but that was a sheet metal piece. But again, it's just a short runner. Is the blower surge hard on parts? I don't know if the on-off is going to be hard on the belt. The rest of the motor, I don't think is going to be a problem. Maybe the blower. I don't think so. I just don't like it. I know whenever we put something on the dyno and Brule is helping, he wants the thing to idle. That's his thing. It's got to idle perfectly. I'm like, I don't care about that. It doesn't matter as long as it's 1500 or something and it'll stay there. That's all I care about. No, it's got idle. It's got to return back. It's got like, especially with the carbureted stuff. That's the first thing is he goes in and does his carb whispering, and so that when it comes back at exactly the right 800 RPM or 700 or whatever he wants it to be, depending on how much camshaft it has. He goes in and does the four corners and gets the and he does it by ear, also looking at the lambda reading and adjusts it so that it has the idle that it likes, and it's a whole process. It's good though. The blower search can be hard on tires. What you need for a 2-valve is a fancy dual plenum, dual throttle body, tubular special, super Richie. And then you need, like what we did on that manifold is we ran a twin turbo setup. And so the guys at HP Performance had to modify one of their air-to-air cores to have a dual in and a dual out, because all those other ones, their twin turbo setups were a dual in and then a single out going into a factory style intake manifold with a single throttle body. And those worked really well. But because of this setup, I'm like, no, it's got to be 2 in and 2 out, 2 tubes, all symmetrical. It looks fancy. Yeah. How about we start a GoFundMe for Richard to get a 3D printer big enough to make whatever he can dream of? You'd have to start a GoFundMe to teach Richard to do the programming for that. All right, Dean, you're out. Wasn't the 95 Cobra a dual runner system like a 99 to 04 V6 Mustang? A 95 Cobra was just a 93, 94, 95. Yeah, 95 Cobra was just a aluminum version with a weird elbow, an aluminum version of the GT40 style intake manifold or the previous Cobra version from 93. It was just a different version of that. I tested that in the videos up on that. Jake, you got several 3D printers? Stack your superchargers on top of each other. I've seen that on pro streetish kinds of things where they have one 671 on top of another one. Personally, I would make an 8 and a 6 and then a 4 and then a 3, and so that you did the pyramid shape. Was a 95 Cobra? It might have been a 351. I'm thinking of the SN95 stuff. Let's see, 95 Cobra. It might have been was that the Lightning motor that they started the base with? The Cobra R, I think, was a 351, right? Yeah. But did they just make a regular Cobra that was like the 302? I'm doing searching. maybe that's the one maybe that's the only one they had that was a 351, right? Let's see. Come on, show me the engine. I don't care about the outside of the car. Yeah, and that still had, the 351 still had the lid that I'm talking about. It said 5.8 liter on it, but the top was not a dual runner thing. It was still just an aluminum version of the GT40 style intake manifold, or the previous 93 Cobra version. Celine also had 351s. They had S351s and then SC351Rs. They had supercharged versions too, right? The 93 was a 302 with the GT40 heads and the rockers and the GT40 intake. And even the Cobra R in 93 was that same motor. They just had different suspension on it, and they took weight out of it. Ever plan on doing diesel stuff? I won't do any diesel stuff on the engine dyno. But you know if 8-to-1 headers are good for power? Excuse me. I don't know. I've never run them on the dyno. They've run them a lot on the chassis dynos. They're pretty popular in sand rails and stuff right now, where they have room to do that. And it does sound good, but I don't know if it does anything. What is the best bang for your buck PCV crankcase ventilation setup for a turbo Fox Mustang? I want to make sure I'm making the engine happy. Well, all you really need to do is, you don't need to evacuate it. You just need to run breathers over to a catch can. And then you can run the catch can as a drain back into the pan. See, Michael, we're thinking alike there. I would like to run 8-into-1 headers, but we'd have to just build dedicated 8-into-1 headers for the dyno to be able to utilize them, because what's right behind the engine. Normally, like in a sand rail, there's nothing behind there, but we have the tower and the electronics and all that stuff there. So we could route it forward and then make a big exhaust, but I don't know if that's going to take away from what it is. And we don't want the exhaust aiming at the console window. So did you wake up from your dream, Milo? Zach, it's not a matter of having an engine that has a exhaust on it. It's fitting the exhaust in the dyno, and the way that most people do 8-into-1s, it doesn't really fit very well. Richard, I'll build some that go below the motor for a 462 valve if you want. But going below the motor is also a problem. It's all the stuff that's behind it. We can't go below the dyno. So the Cobra basically had a half-fast dual runner intake. Are you still talking about the dual runner thing? The dual runner thing was 96 to 98, but it just had an Emmerich plate. They did that so that you could improve the low speed torque, is why they put the Emmerich plate in there, so they could breathe through part of one and one other runner, so that the 4-valve stuff made more torque. I build a set of 180 degree headers for my 97 Z28. Small blocks sound like Italian engines. That's what they did on the Fords for Le Mans. The 98 does have a dual runner. They're the same length, though. The SHO Taurus has a dual runner intake where they change the length. If I LS felt the Blazer, is it a pain to do wiring? Yeah, I'm the wrong guy to ask about that. Yep, 180 degree headers are bundle of snakes. They look really cool in those cars, though. And if you look at the engine compartment of a GT40, it's pretty impressive. Yeah, Admiral, when they say dual runner, I think FR500, just two different runner lengths that provide different power curves. But just having two runners that are the same length, both going to a 4-valve deal, is a different thing. Although they do improve low speed power by putting that Emmerich plate in there. Alex, if you have, this is an interesting question, but when I tell you the answer, you'll understand how easy it is. If you have a 2.4 liter making 260 horsepower and a 4 liter making 260 horsepower, which one spools the same turbo faster? The bigger motor does, because what happens is you're not interested in the peak power number, because that's not where spool takes place. You're interested in what the power is down here. And if they both make 260 horsepower, the 4 liter is going to be making a lot more power at 2000 RPM, where spool becomes important. So it will be making a lot more average power than the 4-cylinder. It makes a lot more low speed power, and that's where you get turbo response. Will vacuum ports still work with a turbo? Yes, the vacuum on the backside of the throttle body, when the throttle is closed, will still be vacuum, but they won't be vacuum when you're under boost. So for things that require vacuum, like brakes, you normally put check valves in those. An adapter to mount an Eaton supercharger like a 122 to an FR500 lower, that would be good. Check valve and yeah, vacuum reservoir you can do. So, Michael, you think the 4-cylinders are bad now because they have open decks? Our Our Bonneville motors were all open decks. I take that back. One of them wasn't. One of them was a sleeved block, a sleeved GSR block, but no deck plate. The other one was a dart block, which does have a plate or has a deck. I think it did, if I remember right. An LS has the same bell housing bolt pattern, not exactly, but lots of them line up. Most of them line up. 2 more minutes. I think we on the B16. I know that we were getting near 500 horsepower with just a stock open deck B16 block. Michael, what 4 cylinders had a closed deck back in the day? 2-minute warning. That's right. Alex, I don't think the exhaust flow would be the same because those are probably going to happen at different engine speeds. Admiral, I don't know what motor you're talking about. Are the 4G63s and SR20s, are they closed? Some H22s were closed, Dick. Admiral, I don't have a 462 valve or a 4 valve anymore, so I wouldn't run those. I gave away my last one. The Ranger Duratec. And they had that in other stuff too, right? Isn't that the motor that they had in the Contour was a Duratec too, right? That's the optimal air fuel ratio. Is it a supercharged motor or a turbo motor or a NA motor? I need to go take a look at Steve Morris's deal. I haven't seen that yet. I need to go watch that. Dan, we like the Iron Duke because it's so bad that it's good. Hipster engine? I think that was way before hipsters, right? So Admiral, you want to build them for a V10? A 10-1? I just want to run an Iron Duke because I've never run one. But actually, there's a lot of other motors or engines that I would like to run. It'd probably be higher on the list than that. Admiral, the guys on the LSs are the guys that want to see the 8-1 headers. That's where they would probably be most common. If you ran an Iron Duke, I think that the S10 had a stronger block. Tractor pullers don't run 8-1 headers. I've never done a big bang on a small block Chevy. I have not run, and this will be the last question for today, for this morning, so go get your projects done. I have not ever dynoed an SHO Taurus, not on the engine dyno, but I was there for years and years and years when the guys from the show shop were doing because they did all their stuff on the chassis dyno. So they built a lot of cool stuff. They had different cams for them. They had 3.2 versions. They had ported heads, stage 1, stage 2, different stuff that they did to the intake manifolds. They had superchargers on them. I don't ever remember them putting a turbo on one of those, although that would have been cool. But they did a bunch of stuff to make them, pretty sporty. So, Michael, you want to see a Gen 2? Well, what's his name? I can never remember the drag race guy that runs that. It was the Tick Performance guys, right? So, Admiral, you want to see 8-1 on a Boss 6.2? Dan, I think you'd be better off trying to get the low budget anti-gravity machine that we were talking about last night. And on that note, it is time to go. So go get your projects done. I got stuff I've got to get done. I got to make some calls. I'm excited about going down to West Tech so I can get that 2.2 built. I like getting that stuff done and hearing it run, because after I hear it run, then I know like all kinds of good turbo goodness is about to happen. Thank you guys all for showing up. I will see you all tomorrow. Or actually tonight.